We are live. Cool. 10:25. So today it's called Systems of Equations. Fancy word. Fancy word. I like to give you the correct math definition, but then I like to come back and tell you in English what it means. So systems of equations simply means how do two lines intersect? Systems because you've got more than one of equations. So you got two equations and we really have two graphs. The solution, the solution or the answer is the point. Is the point of intersection. P, X, comma, Y. P for a point, and every point has an X and a Y value, right? So if I take a look at my first example, the answer is staring at us. I'm looking right at the answer. Can you guys see the answer to example 1? What's the answer? 1, 3 is your answer. My answer to this one is the point. That's it. Where did two lines intersect? At point 1, 3. That's it. Okay, so example 2, we don't know what the point of intersection is, but we can graph them. So I'm going to graph these. Let me use two different colors because colors are always nice for me. I like colors. So let's put the first graph, I'm going to put in blue. And I know when I graph a line, we always start. Remember our starting line? Remember how we put our cars up on the starting line? That's our y-intercept. We start at positive 3. That's my y-intercept. And from my starting line, I apply my slope, which is kind of which direction the cars went. I'm going to go up 1 over 2, up 1 over 2. And of course, if the line goes backwards, it would just follow the same route. Okay, so that's my line. I'm going to connect the dots because lines are nice and long and they go on forever. Okay. The second line, I'll do it in green. I like different colors. It makes it easier for me to see it. Again, here's my starting line. Remember how we lined our cars up? Go down to 1, 2, 3, 4, 5. That's my starting point. In this car, I'm going to apply my slope of down 3 over 2, down 3 over 2, down 1, 2, 3 over 2. It's kind of off my paper, but I can go backwards, right? And so by going backwards, it was actually a good idea because I was able to find where they intersect. Because what I'm really looking for is the point. So my solution, my answer, is the point. Let's see, 1, 2, 3, 4, negative 4, positive 1. That's the answer to the solution. Okay, thumbs up. So if you know how to graph, then it makes it pretty easy, doesn't it? Okay. Okay, example 3 asks a different question. It asks a different question. It's saying, is this the answer? Is this the answer? Well, we could graph them. We'd graph them and find out. Or another way to do it is this. You'll see the first one pretty easily. X, Y. So if I put 2 here, and I put 5 here, what's 2 plus 5? So that works, doesn't it? But it's got to work in both of them. So we're going to test both. It has to work in both, not just one. It's got to work in both lines. Okay, so let's plug it into both equations. It's faster than graphing it. So is this the answer? I don't know. So I'm going to write the two equations side by side, my equation 1 and my equation 2. I just like to make equation 1. I like side by side because it gives me room to work. And equation 2. So I'm going to plug in two, 5 into both. Got to plug it into both. X sum xy. Alright. Alright, so I'm going to go, x is 2, so I'm going to go 2. My y is 5, right? My y is 5. Does that equal 7? Yes. So I'm going to say yes, or I'm going to say true. That's true. That works, right? But it has to work for both. So I plugged in the 2, plugged in the 5, and 7 equals 7. That's true. It's good. So we'll try the other one. All right, so I'll plug it into in for x and in for y. So I'm going to write it like this. I want you guys to be careful on this. I'm going to go 2. And I've got to say this really well. I see this sometimes. You're going to replace x. Don't write x. You're going to replace x. Don't write x. What am I going to write instead of x?
2.
Good, that's it. Don't write 2x. Don't be silly. What am I going to write instead of x?
2.
What am I going to write instead of y?
5.
Good. Don't write y. Just replace it. Does that make sense? Okay, we're not going to make those silly mistakes. So, since x is 2, I'll put that there, and y is 5. Now, do I have a true statement? Well, let's see. 2 times 2 is 4, minus 3 times 5 is 15. 4 subtract 15 is negative 11. So yeah, I mean, if I were to graph these, yes, that's true. And it works for both. So here's what I know. Yes, 2, 5 is the answer. So yes, 2, 5 is the answer. Okay, thumbs up on that. So it has to work for both. Now I think my next example, I purposely made it so it wouldn't work for one, but works for the other. But let's flip it over and take a look, okay? So the same kind of problem, but I picked one I think that doesn't work for both, okay? So here's what I did. I like to write them side by side so I have room to work. Okay, so all right, I'll do that. I'm going to go my equation 1 and my equation 2. My equation 1 is y equals negative 2x minus 4. And my equation 2 is y equals x plus 4. Now I could graph it, but this is faster. Is a solution? I don't know. Here's my x and my y. So I'm going to have whatever my y is. So instead of writing y, I'll replace y with the 0. With the 0. And instead of writing x, I'll replace x with the negative 2. I'll simplify. I'll get 0 equals a positive 4. Negative times negative. 0 equals 0. Yeah, that's true. Yes, true. Which means this point's on that line. But it has to be on both lines. Okay, so let's test it over here. So we'll plug our 0 in for y and our negative 2 in for x. And I'll simplify this. And I've got a 2. And no, that's not true. No. 0 does not equal 2. So it's false. So we can say that negative 2, 0 is not a solution for both. It has to work for both. Because it has to be on both lines. If it's on both lines, then it would have to be where they intersect. How am I doing? Okay? Okay, I see like 3 thumbs up. Only 3? Am I doing okay? Let me see more thumbs up. Now if you're not, give me sideways. I'm okay with sideways. And if you're like 2 thumbs down, then that's okay too. I just need to know. Alright, let me keep going. Example number 5. Alright. Wow, words. as a class fundraiser, you can sell 2 different types of candles. All right, well, short candles and tall candles. So I'm just going to draw a picture. Here's my short candles. I like pictures. Always helps me. Here's my tall candles. No, I'm not an artist. So I've got 2 types of candles. I got short and tall, okay? I could use S and T, but my S's always look like 5. So you guys will get X and Y's. X's and Y's. Let's go X and Y's, okay? And then I've got short candles sell for $4, so I'm going to have a 4X, right? And tall candles sell for $6, so I'm going to have a 6Y, okay? And what I have is this. I've got a total money, so I've got my first equation is money. This is my money equation. First equation is a money equation. 4X plus 6Y equals $144, okay? Now, I don't know how many of each I sold. Could have sold a bunch of the short ones and a bunch of the small ones, or, you know, I have no idea how many I spent. I just know I spent. I sold some of these, I sold some of these, right? But I don't know how many of each I sold, right? But I did another thing, and that is I did sold a total of 28. So that means these candles plus these candles total makes 20. So let's make a second equation. So my second equation is number of candles, okay? So my second equation is going to be number of candles. Candles, and so I'll have an X plus a Y equals 28, okay? So if I could graph these 2, I should be able to find out where they intersect. You okay with that? So to graph them, I'm going to have to solve for Y. Remember, if I'm going to graph, I better solve for Y. And I'll flip it back real quick, because what I'm trying to do is this kind of thing here. Right? I want to do this kind of thing. I want to find out where the 2 lines intersect. So I'm going to try and do this. So to do this, let's solve for Y. Okay, so on my first equation, I've got 2 equations. I've got equation 1, my money equation. Equation 2, my candles equation. Let's solve. Minus 4X. Minus 4X. 6Y equals a negative 4X plus 144. Right? Divide by 6, divide by 6, divide by 6 of Y equals, well, I'm going to reduce that to negative 2/3 X plus, I don't know, calculator time. 144 divided by 144 divided by 6, I get 24 plus 24. Okay, now I can graph that. I might have to change my scale, so I can do that. Okay, equation 2, before I graph this one, which I will, I'm going to graph this one in a second. Let's solve for Y. Minus X over Y is equal to a negative X plus 28. I'm going to put my invisible numbers in there. Helps me out. Negative 1 over 1. Invisible numbers. Okay, so I'm probably going to need to graph by 2's, because obviously I'll be off by paper. Okay, so let's see. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. Yeah, by 2's. I can go by 2's. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. I need 24. 26, 28. There's 28. That'll work for me. Same thing here. I'll go 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28. Okay, so let's try and graph these. Start at 24. And I'm going to go down 2 over 3, or I'm actually going down 4 over 6, down 2 over 3, down 2 over 3, down 2 over 3, down 2 over 3, and it's off the paper. Hopefully that won't matter, because I'm just looking for a point of intersection, okay? Okay, there we go. And the other one, I'm going to start at 28. And I'm going to go down 1 over 1. I know I'm going down 2 over 2, but same thing. Down 1 over 1, down 1 over 1, down 1 over 1, down 1. Oh, found it. Found what I was looking for. Right there. What did I find? I found what I was looking for. What did I find? where they intersect, right? That point right there. Okay, so let's see what I got. I found the point of intersection. That's what I wanted. It's at 12 and, let's see, 12 and, looks like 16, doesn't it? 2, 4, 6, 8, 10, 12, 14, 16. So it looks like it's at the point 12, 16. So here's what I know. I sold 12 short candles, and I sold 16 tall candles. Now, I know I didn't give you guys a lot of time. It's the short periods, but I'm only giving you the evens. There's only 7 problems, okay? Only 7. So I want you to do 2 through 14, page 125, 2 through 14, and the extra is 16, okay? So only 7 problems. You got time to get it done at least tonight, right? Or tomorrow morning early. You guys are sophomores, right? No, you're fresh.